Chapter 3 starts out talking about the three phases of matter, like solids, liquids, and gases. So if we think about a solid, in a solid, the particles are very close together. They're held together by very strong forces, and those particles vibrate a little bit, but they don't move much. The shape and the volume do not change no matter what the container is. So they have a definite shape, always stays the same, and it has a definite volume, meaning the volume of that particular object will stay the same. If we go to a liquid, the particles now have less attractive forces, so they can move more. And they're going to get a little bit farther apart. And instead of just pretty much staying in place and being fixed and vibrating a little bit, they now have the freedom to move a little bit. And that's because those attractive forces are less. Their shape is going to be determined by the container, but they have a set volume. So they have a definite volume, but the shape is determined by the container. Alright, and in a gas, the particles are even farther apart, and their attractive forces are even less. In fact, we say for an ideal gas that they have no attractive or repulsive forces, and these particles are moving very quickly in straight line paths. They have an indefinite volume, meaning they will expand to fill up the container or compress into a smaller container, and they take the shape of the container. Alright, then we go on to the periodic table. And our periodic table is arranged into periods, and the periods we're going to find here along the side. So there are 7 main periods, and then our groups are going to be across the top. So here you can see across the top there's going to be 18 groups. So the groups or the families are the up and down columns, and the periods go across. So for example, if we wanted the element that was in period 2 and group 14, I would go period 2, group 14, and they would meet up with carbon. Now we have different categories. So here you can see there is this dashed line. This happens to be in red. That is the boundary between the metals and the non-metals. So you can see on this periodic table it says metals, non-metals, but anything to the left, those are all metals. Anything to the right are all non-metals. And when we talk about the properties of metals, and I'll put non-metals over here. Metals can be shaped. So we can pound them into flat sheets, which means they're malleable, and we can draw them into thin wires. So they're ductile. But both of those mean they can be shaped. Metals, or non-metals on the other hand, these are brittle. Like if you tried to pound them flat, they would just crumble. In addition, our metals will conduct heat and electricity. However, our non-metals are insulators. And our metals have high melting points, and they tend to be solids, whereas our non-metals tend to be liquids or gases. And I'll show you a different periodic table. And this periodic table has color coded, so the gases are red. There's only 2 liquids that are at room temperature. There's one non-metal, which is bromine, one metal, which is mercury. And then all of the black ones, these are all solids. So there are some solids that are nonmetals. The majority of the metals are solids, but we have the solids, and then we have the two liquids, and then gases. And you can see gases are the nonmetals. Okay, so that's the boundary line. The ones that directly border this stair step, those are called the metalloids. And the metalloids have properties of both metals and nonmetals. And these border the stair step, with the exception of aluminum. Aluminum is a metal. So here's aluminum. Aluminum borders this stair step, but it's a metal. But everything else that touches this stair step, those are your metalloids. And so when you think of semiconductors, which are used a lot in like computer chips, those semiconductor meaning kind of conduct, so those have properties of both. And that's a metalloid. Now we have some specific groups that we name on the periodic table. So this first group, this is called the alkali metals. Alright, so group 1, these are the alkali metals. And then we have group 2 going down, and group 2 are the alkaline earth elements. So once again, this is group 1 and then group 2. Then we have this big area in the middle that sticks down below. Those are called the transition elements. So groups 3 through 12 are the transition elements. Alright, then we can go over here and we have this group, which are the halogens. So group 17, these are going to be halogens. And then the very last group, group 18, these are going to be the noble gases. And the noble gases are special because they have full outer shells of electrons, so these are stable, and therefore they are unreactive. Okay, so once again, halogens and noble gases. Now we call these two groups up on the two sides, these are called the main group elements, and then in transition elements. And the two rows at the bottom, the lanthanide and the actinide series, so lanthanide and actinide series, but those two groups together are called the inner transition elements. Bottom two rows, these are called the inner transition, and the reason they're called the inner transition is because they actually go up here. So you can see 56, and then I would go down here and do 57 through 71, and then I would go back up here. So if you could imagine taking the periodic table and just shoving this whole section over, and then these bottom two rows go up in here, our table would be a lot wider. And we do it this way because we can easily print it on a piece of paper. But those bottom two rows actually go up in there, and that's why those are called the inner transition in metals. Now we do have a couple groups that your book doesn't talk about. You can see on this periodic table these three are bracketed together: iron, cobalt, and nickel. That's called the iron triad, and those are the only three elements known to man that create a magnetic field. So iron, cobalt, nickel. This is the iron triad. Starts with iron, and there's three of them. Another group that's kind of important that we talk about a lot are the coinage metals here: copper, silver, gold. So copper, silver, gold, these are called the coinage metals, and that's because they're used to make coins. All right, and that's it for the periodic table.